Hello everyone, welcome to Skilled Dev. Trey here, and in this lesson we are going to work the question, catch the hacker. And what this question does is it gives you this really long question. It's more of a story, and it expects you to parse out exactly what it's asking, how you need to process the data, and what the solution is that you need to return. And then also, it's going to give us the opportunity to use a very common optimization technique, which you'll use broadly throughout this course, and also very often in your coding interviews. So what this question says is you've created an email list signup. Many developers have added their email to this signup list, but then you have this one person who wants to pull a prank. They're a hacker, and they come in and add their email address, but after adding it, they duplicate this list many times. So there's a ton of duplicates of all the items in the list, but they made a mistake. Their email address has been added more than any other person on the list. So we can catch them by finding the email address that was added the most. So if we really dive in and understand what's going on, it's more of a common problem. It's something that's done often with strings or numbers. And it says, given an array of strings, find the string that occurs most often and return this value. So if we're going to look at the input and output, we write this solution function, find hacker email, that takes an array of email addresses, which are strings, as we can see here, and then it wants you to return the email address that occurs most often. So looking at the input example, we have 3 email addresses. 2 of them occur twice, and 1 of them occurs 3 times. So the item that occurs 3 times is our solution, and we know our hacker is hey@skilled.dev. And now we need to see what constraints there are on the problem. There aren't many, but it tells us that we can assume we have a good solution input. We know the data we're going to receive is going to be an array of strings. We know there are a lot of signups, so we don't have to check too many edge cases or really worry about the input data. We know we can kind of dive in and really start working on the logic of the question. And it also says the output, there's only going to be 1 because we know this hacker duplicated their email address more than anyone else's. So to dive in, we could have this brute force solution. And what it says is we're going to iterate through all the items, and then in a nested loop, we're just going to count the times this item occurs. And then we're going to track the variables max count and email address. And if we have a new max count, well, we replace the previous max count and the previous email. So this takes O of n squared time and O of 1 constant space. We're not creating any new data structures, but we're iterating through this nested list. So we initialize our max count and email to 0 and an empty string. Then we iterate through all the emails in the list. We have a current count and a current email address. And then for every email in the list, we increment our current count. And then once we're done, we can see if our current count is greater than the previous max we had stored. If it is, then we update our max count and the email address associated with it. And then once we reach the end, we just return this email address. And now we want to think how we can optimize this brute force solution. We had this nested loop where we would go through each item and then count the number of times it occurs in the nested loop. This calls an O of n squared quadratic time. But we want to think, okay, how can we optimize this counting? It's a lot of repeated operations. And the best way to do that is adding another data structure. Specifically, we'll add a hash table where the email is the key and the value is the count. And what we'll do is 2 sequential loops, 2 separate loops, where in the first loop, we construct this hash table and get the count for each item. And then in the next loop, we iterate through the hash table and find the largest count. So what we're doing is 2 separate loops. Each loop takes O of n linear time. And because they're separate loops, we can just drop the constant and know it takes O of n linear time in total. And we're getting this improvement over our quadratic time brute force solution because we're adding an O of n space, which is the hash table itself. So what we do is we iterate through each item in the emails array. We repeat this operation for each item in the array until we have our fully filled out hash table with all the counts of all the email addresses. Then in our second loop, we iterate through the hash table itself. We look at the email address and the count. And in this first case, we have a@b.test with a count of 2. Well, we didn't have a previous count, so our max is 2, and the email address is a@b.test. Then we go to the second item. We have c@d.test. Well, its max isn't larger than the current max, so we don't make any updates. Then we have a count of 3, This is the new max, and this is associated with the email address hey@skilled.dev. Then we're done iterating, and this gives us our solution. Our max was 3, and we know the email address, the person who is the hacker, is hey@skilled.dev. And now we're ready to implement the solution. And we know the power of this solution is coming from separating this nested loop and using a hash table to store the counts. The hash table gives us constant time operations, and the separate loops improve this brute force quadratic solution to linear time. So we'll start by just declaring our hash table, which we'll call email count table, and the max count, which we'll update every time we find a new max count, and the hacker email, which is associated with this max count. We'll initialize it to a string to set the type, but we know the hacker email is going to exist, so we don't have to worry too much more. And now we have our first loop, and we just iterate through each email address in this emails array, and we construct the hash table. First, we have to check if the email exists yet, and we say if the email count table does not have the email, then we just add the email address and initialize its count to 0. Then, just on every loop, we increment this count. So this has constructed the hash table for each email address and set the total count for that item. Then we go through the email hash table and we get the email address as the key. So for in email and count table, we get the count by accessing the value at that key. And then we say if the count is greater than the max count, if we have a new max, then we update the max count to be equal to the count for this email address, and we associate the hacker email for that email. So once we go through every single item, we'll have the total max count, the overall max count, and the hacker email that we should return as the solution. And then we run our code, and we got it. So we constructed our hash table and then iterated through the hash table in linear time to get the solution. So our solution overall was O of n time and O of n space. We added an additional hash table, which is the O of n space, and we had 2 linear time loops, which was optimized over our brute force quadratic time solution. And that's it. I'll see you in the next lesson.